Live from the internet, it's the Localhost podcast with Mark Drew and Rob Dudley.
Hello from the internet. Welcome to the Localhost podcast. This is episode 2. We're your guides to various aspects of the lovely world of web development, and every month we get together and discuss an aspect of web development. We shall try to unwrap the subject using questions sent by you, the listener. That's right, we'll be answering your questions every month. Don't forget you can contact us via the Twitter on @localhostfm or email your questions directly to show@localhost.fm. I'm Rob Dudley, and stepping up to the challenge to answer these questions with me is Mark Drew.
Hello.
Mark, how are you doing?
Oh, I'm good. I'm speaking over you again. I shall try not to make that a habit again, but how you doing?
I'm really good, really good. So what are we talking about this week?
Well, this week is Magnum PI. No, CI. Actually, they should do a project.
CI.
Magnum CI. They should do. We're talking about continuous integration, aren't we?
Continually.
Which is continually integrating everything, which is an interesting subject that we do every day, or do we do it every day? I think that's the thing that we should explore, how much we should do it, and whether WSFTP is your favorite FTP program and that's all you need.
Okay.
Do you remember WSFTP?
Vaguely.
It's the 90s striking back.
I'll be honest, I have had a transmit license since, I think, version 2. And until very recently, it has been my preferred file transfer client. It's been usurped by Cyberduck, mostly because the guys at Panic haven't fixed their S3 integration. So you can't actually use transmit with S3 anymore. In any
I was quite shocked that Cyberduck actually did that, went into S3. I think this was one of my... Because I had been using it for a long time, probably like yourself, and then all of a sudden it was... what's this S3 AWS thing? And you could actually just upload it with Cyberduck rather than using some kind of API or something like that.
Yeah, which is kind of cool. But as I say, transmit remains my go-to. But of course, we don't FTP anymore, right? Yeah, the days of FTP to deploy, we shouldn't be doing that.
But how do we do it? You have to get the files to the server somehow, so it has to be FTP, right? At least secure FTP.
No.
At the end of the day, we've got to get the code from our desktop onto the server in a safe manner, right? And people have been trying to do that in various ways. And this is the idea of continuous integration, which is, well, let me rewind. How did we deploy, or how do a lot of people still deploy, I guess, which is hand-rolled. I mean, this is what we were talking about containers last week and how they're kind of sheep rather than pets. But our deployments are like pets, right? Is we have this 40-point checklist that we have to make sure that we've done, that we've repointed, that we've done this. So it becomes an issue, a thing that you're doing, right? It becomes an event of releasing code to the world. And the bigger your app gets, the more of an issue that is, right?
Well, this is it, because you'll make sure that you've wrapped all the files up, you've incremented all the version numbers, potentially you have to do kind of a recompile or a repackage, you've then got to deploy your source code, you've got to deploy changes to the database, you've got to make sure that all of that's in place. Potentially you're doing this over a cluster, so you've got to do this 2 or 3 or n times, and generally speaking you do all of this kind of for some reason on a Friday afternoon, which basically means that you wake up in a cold sweat at pretty much 2 a.m. on Saturday morning, checking your phone, checking your pager, making sure that everything's working, and if something doesn't, you've then got to dig out the previous version to roll it all back. It's basically a freaking nightmare.
Yeah, and who wants...
Is there a better way, Mark? There has to be a better way.
There has to be a better way, yeah. I think the king of the daddy of all of this, or the gateway drug, I think, is Jenkins. I think this has been the game changer. That's what I think. I mean, I might be wrong about this, but once you had some process that gave you the ability to check stuff out and then move it, as well as Ant. So I know I'm getting a bit retro, but the whole point was that you got Jenkins, put an Ant build in there, and even though it was all designed for Java builds, you could actually do stuff like rsync. So you could move the code from your Jenkins server to your live server.
Yeah. And I think in terms of deployment tools, and let's take a little bit of a step back here, because fundamentally, CI is actually it's a glue, it's a binding procedure and set of processes. But actually, there are a lot of different tools that don't necessarily need to be in play, but probably should be. We've seen deployment technology like Capistrano was really, really popular for a long time. We had make files being used to kind of manage off some of this deployment pain. But what we didn't actually have was the final step, if you like. There was still, at some point, there was a click. This is going out. This is going into the world. Whether you were using Capistrano to do that or whatever. So realistically, we then see a combination of different elements starting to work. So Capistrano stops pushing and starts actually using kind of a post commit on version control to say, actually, just give the server a nudge and it can go off and get the latest version. We've also, of course, got the indomitable rise of test driven. So we've now got quality control kind of happening automatically as part of this process. And then you get the magic gateway drug, Jenkins, which says, you know what? Just let me kind of handle all of this for you in a nice, easy package. You configure me once, and I'll take care of it from here.
Right. And I've seen some awesome Jenkins pipelines in my time that do a whole bunch of stuff. For example, update all the clients, update all the different databases, roll back if anything goes wrong. So that goes into another process, and you can really do some magic with that. But does it get too complicated? I think there's other CI tools like Travis CI, which simplified a little bit. They say actually part of your code is you put in your build procedure as part of your code, right? So you put an actual file with it that then Travis can just go and look at the repo and go, all right, that's how you build it, right? Fine. I'll go off and do it. Which in a way you can with Jenkins and Ant, right?
Yeah, I suppose it's with any of these tools, it's a question of the power versus the flexibility versus, I suppose, the minimum amount required of the minimum amount of work required to actually get something up and running. And certainly, in my experience with Jenkins, it requires maybe a little bit more engineering to get you up and running. But at the same time, the end results are very much the same. You can do equivalent setups with both systems. Likewise, I've been using Circle CI on a project fairly recently, and again, that's really kind of laid back, chilled out. It's got very, very sensible defaults, but the power and the flexibility is all there if you want to tweak them. It just speeds up that kind of on-ramp time. I suppose one of the things that is quite important to me when we're talking about this stuff is I was having a conversation with a friend of mine. He's a really good, experienced developer, kind of more in the database side of things than in pure application dev. And he was saying, well, how do you get started? What are the prerequisites to doing continuous integration?
Well, it's version control. I think this is always the first step, right? And the hardest. Good
version control, right? It's got to be version control used right. You can have Subversion, shudder.
Please.
Well, I don't know why I've suddenly become such a Subversion snob, by the way. Subversion served me very well for many, many years. So my apologies to the Subversion community. But yeah, realistically, we're probably talking about something that has a solid branching model, so it's Git, right?
Right.
And you need to make sure that you've got your branches set up correctly so that you can work safely on your project within this kind of structure.
Do you use Git flow? I mean, this is the de facto flow, I think. I haven't seen anything that replaces it. I think Git flow is the way to do it. I guess we should say what Git flow is for people out there.
Yeah, anybody who hasn't heard of this, let's hope that you understand Git a little bit. Otherwise, you're going to just tune out for the next 30 seconds. So Git flow is a standardization of how we manage branches within a software project. You have your master branch, which is always ready for production. You have your develop branch, which is kind of your staging branch, and your developers can basically spin off feature branches that come off the develop branch. and work on new features, merge them back in, and then you can do other things like performing releases. So this basically merges develop back into master. It sets up a tag for you. And because it's quite pragmatic, you do have things like hot fixes for emergency. Oh shit, we've got to fix this thing. And that kind of merges into both master and develop. But fundamentally, what you get is this solid structure that means that you can be working on the craziest teardown rebuild of your project ever in a feature branch. Develop is still usable for testing and staging, and master is always 100% clean, or should be, right?
It should be. I mean, I think in most experiences, master has been what's deployed. I mean, the nice thing about that is also the tagging stuff. So you can actually, but Git flow allows you to tag the master, saying like this is the actual release, so that when you when it all goes wrong, as you alluded to, the master not being so clean, you can actually go to the previous tag. And say, like, actually, we're going back, but the rest of our version control doesn't have to go back along with the release. You just know what's been released. You can move master back and say that the rest keeps on going and you can fix it.
This is it. So what we end up with is a very sensible structure for managing our project's code and our project's, I suppose, state within its development lifecycle. And that's kind of the key foundation. If you try doing CI without something that is as robust as Git flow, you're going to come unstuck.
Right. I mean, otherwise...
That said...
Okay.
You don't have to use Git flow, right? You can do this by hand. The reason that developers like Git flow is it's a series of kind of extensions to native Git functionality. It doesn't actually add anything particularly new. You're still just dealing with branches, you're merging and what have you. There's nothing to stop you doing that by hand if you want to. You can have develop branches, feature branches. You can blast all this stuff, roll it together. You might be like, well, it's just me. I don't need all of this power. But at the same time, it is so light. It just stays out the way. And honestly, once you've used it for a project, you are probably never ever going to go back once you get that first hot fix through and realize that actually this hasn't messed up my development lifecycle. It's all completely fine. So don't have to use Git flow, but you do have to have a solid version control branching structure.
Okay, so Jenkins, is that part of your live server? Is it another server? I guess we have Jenkins servers, right?
Yeah. Well, think of it this way. If we take this is my approach to it anyway. We take the standard kind of server setup. You might have your development machine or your development environment, possibly Docker, but let's not over-egg this just yet. You'll normally have some kind of staging environment, and you'll normally have a live environment. And the idea being that your staging environment can mirror the live environment very closely. It's running on the same kind of hardware in the same kind of data center. It's running the same kind of OS. So you've minimized all of those issues. This presumes that you're not using something that solves that for you, Docker.
We're not sponsored by Docker, by the way.
We're not. We should be.
Definitely.
By the way, we've given them serious props for the past month. Come on, guys, show the love. So we've got our staging environment and. Realistically, you've got a couple of choices. You can run continuous integration at any two of those 3 points, or you can inject a fourth. There are some people I know run this stuff purely locally. They have the system running on their dev machine. This is probably not a great idea, by the way, but you can do it. And it kind of spins out, runs the test, and it's like, yay. And then it does the push release. Realistically, more commonly, what you'll find is an additional server or an additional environment creeps into the mix here. So we kind of have somewhere where we can stage the stuff and kick it around, but we also have the continuous integration environment, which is spinning up every time we make a commit. It's running all the various checks and tests. And in its simplest form, it is deploying the latest clean live version of your system. The reality is it's probably also deploying the latest clean development build of your system.
Right.
So, if you've got this and you've gone to all the effort of configuring it, which isn't masses, but it's some work, why would you not have this also managing the state of your staging build and kind of handling deployments that way? So new commits go out to development, it runs the tests, it does whatever it needs to do, it does the asset pipeline manipulation and all of these other little crappy jobs that previously we just had to remember to do are done for you, and it does that for staging, and it does that for production off the master branch.
Right. I think that one of the core concepts here is that I think we might have missed saying it, is that deployments now become continuous. In other words, that they happen a lot more often. They're not a big event. You don't have a big bang deployment. You have actually lots of stuff coming through. So you don't have, this is version 1 of the server, this is version 2 of the website. You now get like minor versions, so each tweak, each feature makes it out a lot quicker. And I think this makes for a better environment because you have less to test. So you have QA just working very quickly on whatever you've just worked on, whichever feature, the nice drop down or whatever. And then you have your clients or, your customers seeing that feature, and you can introduce them to that small feature rather than here's our new website and I have to give you a nice intro to the whole website. Says my dog in the background agreeing with me.
Dogs do continuous integration, by the way. If you weren't aware of this, all dogs, all the time. Yeah. So, I mean, you're absolutely right. This is about reducing the gap between those releases. And in fact, depending on how far down this road you go, it can be reducing the concept of a release altogether. You do a feature, it's clean, it works, everything comes back green, it's released, and that just happens. Now that realistically might sound like a bit of a daunting prospect for somebody who isn't doing this. But the reality is, once you get it in, and once you develop that kind of trust in your own systems, in your own testing, it becomes incredibly liberating, because it means that that this thing's clean, that it's just going to go straight out there. There's no waiting around for the next release cycle. There's no issues of having to worry about kind of regression from other features as well, because you're not worried that actually this change I'm making here might knock onto this change that I did 2 weeks ago that is still waiting in the release queue. So it kind of frees you up to be much more, dare I say, agile in your approach to software development.
It's also brave as well, because you can see things breaking quicker, and you don't fear breaking stuff. And this is a big problem in some software projects. Okay, so we all have 100% test coverage of our projects, right? But in case that 1 or 2 people out there don't have that, if it becomes such an issue that you can't do a build very easily to discover if your changes affect something else, because you just don't happen to have tests on it, which you should have tests for everything. It's also finding out how you can be assured that your new feature is working, essentially, as it should.
Well, yeah, this is get it out there. Get it out there quickly. Make sure that your monitoring's on point, and fail fast, right? You want to make sure that if you do have an issue, you're aware of it, but at the same time, it should be a small issue. It's a knock-on. If it is a bigger thing, and this is a little bit trickier to manage, you need to make sure that this is not going to remove the need for you to actually test your code and understand what it is your code is doing. There are situations where actually pushing out an entire feature set just automatically may not be desirable. There might be projects that are a bit more critical or have QA requirements, and that's completely fine. CI still helps, because it can actually manage that process of making sure those features make it out to the next stage. And
that's a separate subject that we should hit on, actually, maybe in a different podcast, and it's called feature switches. Which there are Java projects out there that allow you to put a feature out, but you don't only implement it. You only implement it when you've switched that switch, so to speak.
This kind of thing sits alongside that. You have to have this this trust in your deployment pipeline to be able to run something like feature switcher, which we can talk about a bit more later on, potentially. Otherwise, you just end up with a whole bunch of feature switches, and then you're not too sure exactly which switches are doing what, and you've got this big ball of mud release again, which is not great. In terms of the other prerequisites, I mean, you talked about testing, and yes, of course, we all test. So we have 100% test coverage. We've got our functional tests, which is all super shiny. One of the things I would say is that to those who are looking to start this process and don't necessarily have that level of test coverage, don't let that stop you. Right? Maybe don't jump off the cliff that is full automated deployments, but you can still, there's still stuff that you can test and run using a CI environment. There's still tasks that need to happen, and it will still save you time. So if you've got, say, asset pipeline pre-compilation that we talked about, you might have some kind of client-side build. You're running Sass or PostCSS or a framework to manage your front end. That can all form part of your deployment. Also, most languages come with a basic compiler or linter. Let's just check for syntax errors, for God's sake. Run the unit tests you've got, if you have them. Run the functional tests or the front-end Selenium tests, if you've got them. But get this system in, and you'll start to see how it's going to make your life better, easier, and more productive. And realistically, it will give you the impetus to actually improve that test coverage. Because when you see that kind of the build goes green moment, you'll think, actually, I want more trust in that. I want to build on that foundation of faith in my own work.
There's a project from the CFML world, and I'm going to have to shout now over my dogs deciding to kill each other in the background, which has got the beautiful name of Cloudy with a Chance of Tests. It was done by Mike Henke, and the great thing about it is that it's a build XML file that you can just chuck into your Jenkins build, and it for CFMLers. But I guess the process is the same for any other project. Allows you to do a whole bunch of stuff like linting, like checking for variable overflows, checking that you've parammed your SQL, or checking like you've got like basically linting now. But it also, this is way back. I say way back, from about 4 years ago. And this was a great thing to get started with, just looking at all the different processes that are in here. So I'm going to just do an example. It cleans. In other words, after you've done all your processing, you might want to get rid of your tests before you go to live, right? There's a whole bunch of folders that you want to get rid of. It cleans a workspace. Obviously, you want to start with something clean. It removes documentation, for example. You might have documentation in there for other developers, but you want to remove that. Also, documentation in external projects, like if you're using CK Editor, right? Who isn't? I mean, I jest, but if you're using CK Editor, there's always those PHP files, for example, that you might not be having a PHP project. So you don't need those as another vector of attack. So you can get your CI engine or your build project removing all that stuff that you need for development, but you definitely don't need for going live, right? And it's got some scripts in there which were great, which were database creation and database updates. So what you could say is actually my database is at version 10, for example, just like you have a schema versioning, and it would only run the scripts from version 10 upwards, right? And if you're creating a new database for whichever reason, you could have all the scripts that only run if this is the first time that it's run, if there is no database, and a whole bunch of other processes. I mean, the process would be different, but this is a great project. I'll put the link in the show notes to get started with. Other things about continuous deployment that I think are really important is playing the blame game. Is that you got tests and they fail, then what? You do a deployment and it fails, then what? I think one of the big, people start doing deployments and you get it onto the server, and that's great. But that's always step one, is what happens when it fails, right? And one of the great articles is called Quantum of Deployment, which is a great title for an article. And this was done by the Etsy engineers, and they were deploying hundreds of times a day. So they had a whole bunch of developers working on it, and they kept on deploying stuff out. What they got to was a point where they were deploying, hundreds of times a day, and basically they had canary situations. So you had this one feature going to this one server, they put some of its traffic to it, and if it passed the tests, they had the monitoring, as you say, it would then go into the cluster, and that change would then deploy out until it stopped, and then they roll back. And they had this little machine, this little script that they called I believe it's called the deployinator. Had a great name. Yeah, it's deployinator, which was part of their QA. So this is back in 2010. So it's a great article to get started on understanding real CI in a real environment. And I'm sure there's loads of people there doing much bigger rolling deployments than we are. I believe Facebook does this weird single 2 gig binary deployment with BitTorrent.
Okay.
Yeah. The problem that they had was, which we will have, and I've encountered it, is that, okay, so if you're physically deploying to a server, what are you doing? You're changing a number of files. And if people are actively going to that server whilst those files are changing, what's going to happen? In CF, for example, if you hit a CFML template, it compiles down to Java. But what happens if that CFML template hasn't fully been written when the engine is asked to compile it? Right? You're going to get this weird error that then when you go and check what went wrong, it's not going to be there, right? Because the template's been written and you were getting errors. So you had failure of service, but it was a momentary lapse of reason on your machine's part. Right?
This is inconsistent state of your application, right? You've got some code that has rolled on to the next release, some code is still behind on the previous release, and that will cause issues.
Facebook's solution to this was actually bundling all up. It was one binary, whatever, a couple of gig, I think it was. We can check our facts later, or not. And actually what it did was deploy it using BitTorrent. So bits would spread very quickly across their cluster, and only when everything got in there would the binary switch over. And that's like a on-off switch from current to other one. There is a product that I love that has got a feature to it, which is awesome. And that product is DeployBot. Again, we're not sponsored, and we should be totally. I should be wearing their t-shirt, which I use all the time, which is a super simple way to get into all of this. What is based around this idea of repository. So you say, this is my repository, I'm going to deploy it. And you can add hundreds of servers to it. You can add production servers, you can add staging and test servers, or whatever you want. And it automatically deploys it there for you, right? What's interesting, they have this thing called Atomic FTP. So if you're deploying to a Linux-based server, what they do is actually deploy to a folder, which is a version, until the deploy has finished, and then they symlink it to the current, and they do the swap. Exactly. So it's super great, because you know for sure that only when all your changes have gone on will it then swap the code round. And this is to solve that change. But it also means that you can very quickly go to your previous release.
Yeah.
Right? So it checks out your whole changes, and then you can quickly go back to a previously released version of the site. But that's super quick. Rather than I now have to check out the previous version, it's literally just change the symlink, change the current to a previous one.
Now that is really, really cool. And it does speak, I suppose, volumes about the actual, once you start using this, you will run into consistency issues and what have you. But the benefit here is clever people have been working on this kind of stuff for a while. These are all solved problems. And whether or not it's DeployBot, or whether or not you roll your own kind of hot swapping, rolling deploys across clusters, whether or not you're using containers so you can just tear up, tear down, whether or not you're just deploying to something like Heroku is a really good example. They do all of this kind of project building on their end. They will not swap your application until that finishes clean. So you get this atomic release, which is exactly what we're talking about here. But yeah, you need to be aware of it, and effectively be aware that if you are just allowing your continuous integration to effectively do a git pull and then run some tasks, those tasks are going to take time. And if you do have a requirement for consistency in your code throughout the release, you're going to run into problems unless you manage it.
Right.
But it's manageable. Two things. Firstly, I found the Facebook BitTorrent deploy system. It was a 1.5 gig binary blob that they were kicking around.
Sorry, I thought it was 2. I was rounding up.
It probably is now, right? There's a couple more cat gifs, a few more emojis. They're probably up to about 2 gig at this point. Also, if you're interested in massive deployments and using BitTorrent, have a look at Twitter, because they do something very similar. But they actually use it more for to overcome networking issues as they run the deployment. So they feed it in, they seed it into one end of the network, and then it replicates out. The other thing I'd say is you started talking about the blame game. And this is quite interesting in terms of quality. And this is not so much continuous integration. This is more kind of the psychology and I suppose the philosophy of good software development. There's absolutely a need for anybody who breaks the build needs to be able to own up to it. They need to be able to see it. Not so that we can blame them, right? Not so that we can throw rotten fruit at them and what have you, but so effectively you can avoid it happening again.
But of course, in Git, it is called blame, right?
It is, and I'll be honest, that's probably down to the fact that, who wrote Git. He's quite acerbic. But the reality is, what we're looking for here is not necessarily blame, but apportionment of responsibility to avoid repetition.
Right.
If anybody's interested, there is an amazing book called Black Box Thinking, which talks exactly about this kind of process, and it's the difference between the way the example used is the way the aeronautic industry avoids failure to the point where they don't fail in any meaningful sense, in terms of you run the numbers, versus other similar complex industries. And actually, it's all about the really obvious things that we do. It's about taking responsibility. It's about making sure that you've noticed when this stuff has happened. So when we say you need blame, we don't necessarily mean blame. You need to be able to
as in pointing fingers.
We need to be able to apportion failure, but in a positive way.
This was something I used to work with a guy called Sean Caulfield, and I managed to break the build. And this was to my credit, this was a difference between the OS X and Linux file systems. So like it passed all the tests on my machine, but it failed on Linux, right? And I learned a lesson from that, right? It was like, and now I'm a bit anal about capitalization and things like that because of that. So this whole blaming thing, I broke the build. People got angry at me because I broke the build. I learned an error, and I've never forgotten it, right? So this is a very good example of improving as a person through failure.
At the same time, I've worked in teams where realistically we have the cone of shame, the silly hat that gets proportioned to the team member who's broken the build more times that week than the other. They're all good fun, and they kind of they I suppose keep you positive and on track, but never underestimate the cultural impact of what we're trying to achieve here. It's about improvement, not necessarily about loser. Cool. Okay, so I
was just going to interject. So that's still part of this blame and the system working is this brings in the whole idea of having a traffic cone system, like a physical. I think there was some. I can't remember the startup in San Francisco had a physical traffic light. Like a 3-foot tall traffic light that they'd got from the council or whatever's equivalent in the United States, and they'd wire it up to Jenkins so that they could show you the state of the build, and it would be a physical traffic light in the studio as you were building stuff. Which brings me on to Tim at Cat Light has created a product that does that, but instead of being a physical traffic light, because that could get a little bit annoying, goes into your status bar. And he contacted us about one of the typical problems is knowing who broke the build or the state of the build. Because unless you go to Jenkins or whatever your CI engine is, you don't know the status of the build unless you might get an email, for example.
Yeah.
And we are covered in emails and Slack teams.
Well, I think this is the thing is I've not actually used Catlight, but I'm going to check it out. So because the one thing about CI is if it operates in a vacuum, it may as well not be there. You need to have visibility into what's going on, and that can be as simple as is it broken, is it not? Red and green, passing, failing. Realistically, you also probably want to make sure this thing is broadcasting into Slack, insert name of chat channel here. This is exactly what Hubot was built to do by GitHub. They've got this kind of framework that allows you to talk. There's all sorts of bot frameworks, right?
So what's a Hubot?
Hubot is GitHub's bot framework. Okay. So it's designed to basically take messages from an automated system and push them into something like Slack. There's a Slack connector.
Oh, I see.
Or push it out over XMPP. Insert name of chat framework here.
Right. I actually did that yesterday. We had a hand-rolled integration for some clients. There is lots of reasons that we could have, and we don't have Jenkins running in there. It's actually a simple script that gets a post-event hook from Git that then deploys the code to the dev server. Right?
Yeah, nice and simple.
And it's actually on the dev server. It calls itself and it just checks stuff out, right? The problem is that and it also clears the template cache. So if you have systems that have template caching, we would never know whether our part was actually deployed without having to RDP into that server, look at the file, and even if the file was changed and actually committed, we wouldn't know whether the template cache had been run, right? So now, after the process, I actually get it to, and this is really simple actually. In Slack, get it to send a message to Slack. It's just a simple payload. And I know that you do another podcast, don't you, you traitor?
I do. It's
We're Drunk and We Know Things is the title, I believe.
Yes. It was originally going to be We Drink and We Know Things, but that one was taken by a Game of Thrones podcast. But yeah, I mean, the idea is that this is a friend of mine who knows a lot about movies and me who knows something about technology, and we basically get together, have a few beers and educate each other. But yeah, the last episode was talking about bots and how those can kind of replace various elements, but that was looking more at kind of the rise of the automated communication framework. I suppose in the context of CI, what we really need to make sure is that whether it's email, whether it's Slack, whether it's traffic lights, or better yet, all of those things, you need to be able to see what is happening in such a way that you can get the quick glimpse. Is it green? Great. Or you can do the kind of, actually, I need to monitor this because I know that I've got the whole team is working on a massive sprint. We've got a load of features coming out. Let's just see how this goes. Keep an eye on it.
And from your podcast, I was inspired to make sure that I am notified when things go right, and also when they go wrong. Which I've seen sysadmins machines, and they get so many notifications. So I think you have to have a proper escalation up. Like if the test broke, okay, so inform the right person, the person that did the last check-in, for example, or it runs a blame on whatever the line of code that failed, for example. But if your deployment to live failed, I think the escalation has to be higher than just, you should really look after this. It's, klaxon should sound.
Yeah, that's pretty much the. I've never actually been able to do it, but I've always got this dream that one day I will have the techie kind of knock center, where when you get that kind of critical braking failure, there will literally be orange lights start flashing, sirens start wailing, and steam starts getting ejected from cans that just contain steam. They're just there for the effect. But yeah, so
you turn your office into the set of Alien Covenant.
Yeah, pretty much. But only for those brief moments when everything goes horribly wrong. I mean, I have actually seen people do this where, and this is a genuine thing, if you're using like IoT, you've got these smart light bulbs like Philips Hue. And they do actually have, this is really, really cool, they have these kind of in their office and what have you, and when the build breaks, the entire room goes red.
That's horrific.
It's a little bit scary, but again, it's about visibility. It's about making sure that you've got escalation. It's probably a bit extreme, although I quite like the drama of it. Although you can imagine if you've got a client in for a meeting and the room is suddenly filled with red smoke, going, "What the hell is that?" It's all right. We forgot to clear a template path then. But yeah, so there's all sorts of cool things you can do. And I suppose the other thing is, whilst this is deadly serious, this may not be life and death. It might be, but it is certainly professional. You're getting paid for this stuff. People care deeply. Have a bit of fun with it. Make sure that your CI system is chatty. Make sure that you've got a genuine traffic light, whatever it happens to be, because this is going to become central to your development culture. And the best way to get people to buy into this, to kind of accept ownership of this new system, is to actually make it welcoming, make it a bit more fun rather than very dry and lots of emails and very serious.
You have broken thy build. You have. Thou shalt be penalized.
Cool. So I kind of have a question for you, because I tend to do this stuff based on a subset of tools, and I use the same tools all the time because they're the tools I use. So if we're using, say, Jenkins, or we're using Travis, do we have similar tooling available to us to handle all of these integrations? Because it sounds like what we've just talked about is fun, but I'm going to spend like 3 weeks wiring my office for emergency steam, and then another 4 weeks finding the microcontrollers to actually activate it over the internet. So is this kind of stuff all handled for us in most of the continuous integration platforms that are out there?
I think there is a standard way of doing this, which is by webhooks. If that's what you mean, is both Jenkins, I'm pretty sure there's a million plugins for Jenkins. So Jenkins will do whatever you want it to do. It'll call webhooks. It'll call other tasks after it. So the other task could be a plugin into Java that calls the hue lighting controller, for example. I'm pretty sure Travis has got like post build hooks. And well, the web runs on HTTP, right? So most of these things have got some way of calling something once it's done. I know DeployBot has got beautiful connections into everything. So you can do a pre-commit, pre-build webhook and a post-build webhook, and you can do it that way. And that seems to be the standard way because it's a simple way, right? Unless we went back to the 90s and said that you had to do it via SOAP or something like that, which I don't think would have taken off.
Or Corba.
Oh, yeah, Corba, of course. Yeah.
Okay, cool. So, so to kind of quickly summarize, make sure that you've got this system emitting information. It's really easy to do in all the systems. If you happen to be using the only CI system in the world that doesn't have this kind of ability to broadcast or is really restrictive, honestly, bin it, get rid, get one that does. There are plenty out there to choose from. There are some that are kind of agnostic, platform agnostic. The majority, to be honest. There are some that are a bit more specific. I know that PHP's got its own CI system, which is kind of cool, I suppose, because it's, if nothing else, if your team is purely PHP dev, then you can pretty much script it in PHP, so you don't have to worry about additional languages or XML configs or similar. But yeah, so make sure that the system is in, make sure that people are using it, make sure that it's telling you what's going on.
Okay, so one of the other projects is drone.io, which is, I think, is very similar to Travis. I haven't used it. Have you? I guess you haven't heard of it either.
I haven't, although looking at it, I'm kind of surprised I haven't.
So there's no hosted version, but basically it's a continuous integration platform built on container technology. So it's like fully built on container technology. This is one of the things that I have on my to-do list to inspect stuff. And how you do it, as far as I understand, and everyone's going to shout at me in the show notes or afterwards, is basically you put a drone YML file into your project that says, I want it to be built like this. And I think that's the way a lot of CI engines are now saying, because they're becoming kind of a less agnostic. They basically just say, give me the repo and I'll handle it from there, right? Rather than the Jenkins way, which is like, well, let's configure a job and we'll figure out how we're going to do it. All of these things are like, give me a repo and the repo will tell me when it's changed and I'll build it. And I'll build it by a file that you tell me what to build. So that's how Travis works, as far as I understand it.
Yep.
And there's the same thing for drone, which is another one that's coming in, which I need to check out. We'll put it in the show notes. And it's
okay, so this is drone.io.
Yep.
And looking at it, we've actually... you've got a couple of interesting things. Firstly, it is built on Docker, and not to go back over the previous show's ground, but realistically, containerization changes CI massively, right? Because it does mean that we can actually effectively hand off on the containerization layer a lot of the deployment boilerplate that we would previously have had to have script in. So being able to say, actually, this is the environment that I want to run the tests in, this is the database that I want to run the tests in, and just spin it up, tear it down, is made that much cleaner and simpler. So yeah, drone.io looks really, really interesting. I too will be investigating further. They've also got what looks to be quite an interesting front-end CI offering.
Oh, yeah.
So drone UI in the same repo, which looks like it's targeting React at the moment.
Okay.
We haven't really talked much about the problems facing front-enders.
Oh, God.
And front-end testing.
Because Webpack... I tried to look into, and this might be for a later show, but I just tried to look into one thing, and it led me down this path of yak shaving, because I had to, find this other thing, do this other thing, do this other thing, and I was going, I would just want to build one component, and before I knew it,
No. Welcome to the universe of front end development, right, in 2017.
But the problem tied to that is that how do you test all this stuff? How do you deploy all this stuff? Now you've got all these build tools that you have to use locally on your development environment, but then how do you get that to production ready state? Which is what your CI is meant to be doing, right? That's what your CI will do for you.
Yeah. Well, I mean, realistically, I suppose all of the tools are there, but effectively, when you do a build, you need to be handling both ends, I suppose, to sort of massively oversimplify. But your server-side code, your unit tests, and what have you are all good. Presumably, you also have test coverage on all of your front-end stuff. Of course, you do, right? I don't. I'll be honest. I suck at unit testing JavaScript.
It's very hard, actually. That's one of the bigger problems that we've had, because we test all of our server-side code, but then we go into a UI code, and it's like in the projects that I'm working, some of them are quite big. So they're like, well, how do you test this? It's like we've got some Backbone, we've got some jQuery, we've got some React going in, and it's like, yeah, you got to test it, and there's incongruent versions of frameworks and different testing patterns. So
yeah, but again, being able to cleanly kind of install all of your dependencies and actually make sure that all works. Even something as simple as JS linting, again, just make sure that your JavaScript is clean and runs. And then realistically, we're kind of into automated front-end testing, which is a whole different subject because it's huge. But this is basically things like Phantom JS. This is Selenium, allowing you to effectively not worry so much about the internals of your JavaScript's structure, but actually how does this stuff actually work? So front end definitely has a part to play in continuous integration. It is slightly more complicated, I think, and slightly broader and deeper and wider and generally harder. And also, if you are listening to this and you have got a really successful kind of full stack CI system up and running, please let us know. We would love to talk to you about it. We'd love to hear a bit more about how you've solved these problems, because we've all got our own different variants and our own various approaches to this. So if you've got this solved, then yeah, get in touch.
How can they do that, Rob?
Well, they can send carrier pigeons to... No. The best way to reach us, it depends. If you want to do this kind of privately, you can just drop us a good old-fashioned email, show@localhost.fm. If you don't mind being a bit more public, then by all means tweet at localhostfm. And if you can't remember any of this, then it's all on the website, which is localhost.fm. Which
is very easy unless you do a lot of development, because you keep on typing localhost and going, I can't find their site. It looks like my site.
Yeah, we're totally trolling all of our listeners with the name of this podcast. Localhost.fm, port 3000. Also, frankly, if you happen to be consuming this podcast on one of the many, many channels, we're on iTunes, right?
Yep. We're on iTunes. We're on all the podcasting repos, which is actually easier and harder than it sounds. You just have to go and tell them that you exist, but then you don't get any feedback whether you exist. So you have to download and install and find out if you actually exist on them. But we're everywhere. You can find us everywhere.
Yeah. So if that particular channel, if you're on iTunes, I don't think you can comment directly, but you can like us. You can give us a rating.
I think they
would be good.
They can review us, and we'll get notified that you are asking questions.
If you're listening on SoundCloud or if you're listening on YouTube, there's a comment box right there. Use it. Drop in your notes. I know some people have, which kind of brings us neatly onto a section that I can see in my show notes.
Oh. Is there a song for this? It's your feedback. It's your feedback. No, we're not going to make a song for this, but yet.
No, you just have to imagine it. Okay, so this is obviously, as we said, episode 2. Prior to this, we had episode 1, which was all about Docker, and we had 2 kind of develop branch episodes where we were talking to Jeff and Mark, and they were really, really good. And we have feedback.
Yes, we have.
Which is amazing.
So I made a boo-boo in episode 001.2, which I said that DigitalOcean, who are awesome, by the way, and you should totally sponsor us, we're actually using AWS's servers. They don't. They're using their own servers. They have servers in Frankfurt and various other areas which AWS doesn't. They have actually London-based servers
AWS actually are in Frankfurt, right? Just before anybody else gets on the horn.
Right. I forgot. Sorry.
Mark, just stop talking. Stop talking, man.
They have one in London. AWS doesn't have one in London. It's in Ireland.
Again, not sure that's strictly accurate, but right. Okay, so
the regions. Anyway, they have their own servers.
DigitalOcean have their own.
Have I just
servers.
created more feedback for ourselves? Sorry.
It's a feedback loop. It's brilliant. Okay, so thank you to all of those people who corrected us on that point. Please don't feel the need to correct us on our lack of knowledge of where AWS actually is. After all, remember, it doesn't matter. It's just the cloud.
The cloud, capital T, capital C.
Okay, so what else did we get in terms of kind of feedback?
It was the Windows containers. It's like Docker for Windows. There is Docker for Windows, and it's got the Windows Server core, so you can run it. I need to. It's not obvious whether I could run that on my macOS machine. I think it needs to have the underlying host to be Windows.
I don't know. Is the simple answer. I would assume so.
But Microsoft have a lot of projects there in Docker Hub or hub.docker.com/u/Microsoft. You can see a whole bunch of stuff. So they've got IIS containers, Windows containers. So yeah, if your host, your deployment environment is Windows, you can totally do this. You can totally do the same things that we've been talking about. You're just using a different host, and you're using Microsoft tooling, which is awesome because, again, this just fits straight into this CI episode because you're not limited by the underlying operating system anymore.
No, not at all.
And that's Justin Carter again. Thank you, Justin, for your feedback there.
And he also kind of threw in another point, which I agree with. We were talking about Tomcat, we were talking about web access and what have you. And Justin has mentioned that actually dropping a web server container directly in front of, say, Tomcat is actually not a bad idea from the perspective of flexibility. It's not needed. You don't necessarily get the massive performance gain, but it does give you a lot of stuff that Tomcat either can't do or isn't great at, and things like SSL termination and rewriting, redirecting. And if you're using, say, Nginx, then you've got a really good solid asset cache and what have you as well. So, I would always kind of follow that architectural pattern. I'll be honest. I would nearly always, if it's a web application, I've always got a web server in there somewhere, between the gross general public, and
what would you put it behind the load balancer? So you have the load balancer going to the web servers, going to your app servers.
To be honest, the last project I did big deployment for, the web server was the load balancer.
Okay, so it was like an Nginx load balancer.
Yeah, Nginx was doing the load balancing and the proxying, and it didn't seem really necessary for the load on this particular project to spin up a whole HA proxy. Generally speaking, yeah, there's HA proxy kind of managing stuff. And frankly, if all you need is SSL termination and load balancing, then HA proxy does a pretty good job of kind of being that extra layer and that extra bit of flexibility. But don't feel that you absolutely have to just expose Tomcat to the web. It's great at it. It's amazing. It's wonderful. But yeah, that additional bit of flexibility and customization that you can get can be really useful.
One thing that I did part of one of the internal CMD projects this couple of weeks was an interesting one, because let's say you have a database that you need to seed with some data. I was never able to solve that problem quite nicely because I kept on using just one container. So let's say, for simplest sakes, you have a MySQL database that's part of your LAMP stack or whatever, and you bring it up in a Docker Compose type scenario. I never knew how to seed that with initial data, right? Mm-hmm. If you've ever had to do that. And I found out the solution, or the clean solution this week, is actually to create another container, which is a MySQL seed container. So actually, you have two containers: your MySQL, your actual server, and another one that it's also like a MySQL one, but it's just so you get the tools. You don't have to start it up. So you create a Docker file that says like import your SQL files, and then you run a command which is MySQL import onto your actual main container, and then that container dies off because it's done. Once it's done the seeding, it stops being a server because you've overridden the default command, the default entry point.
Okay, Yeah.
And you can do this for MongoDB. So I think they call these sidecars. I might be completely wrong about this, but basically it'll start up at the same time as part of your environment, do the load, and because you can link it and do depends between them, and if you use Docker Compose especially, you can depend. So one container can depend on another. So therefore that one gets started in time. And that was a beautiful, clean solution that I was like, a kind of, the fog disappears, the fog of war disappears, and you go, I can see clearly now. This is a good way to do solve this problem. But yeah, so that's a follow-up from our fun in the land of container. And there we have final bit of follow-up. Jeff, after his interview, did post back saying that Docker now has secrets management, so you can actually have a vault of sorts that actually manages all your secret keys, and it'll inject them as environment variables, I believe. I still have to work my way through this to make sure that it's all working. But we'll put the link in the show notes so you can have a look at how Docker suggests to do that. They actually have a lot of other things happening in there. They're holding a whole enterprise ecosystem now. So I think they need to hit the big enterprise, and as part of that would be the secrets management for those requirements.
That makes sense. I mean, it's definitely a requirement in pretty much any project once it gets to a certain point, right? So,
right. Well, I mean, it's even simpler. Like, I think I have small projects, and you have the API keys. It's like that's how you have to connect to whatever. If it's GitHub or AWS, you got your AWS tokens, so you can store your stuff. So it's not even like a big project. Let's say a small project that you want to containerize. You want to store your stuff in a permanent storage, which could be S3. Now, where do you keep your keys? Right, you keep them in your Git repo, of course, so that people can then at a later stage come find them, which is the wrong way to do it. You want to keep them as environment variables, so they're ephemeral and they just disappear. But this is a good way to manage that. So you put them into a vault, and then you give access to your Docker to container to access the vault, and then you can revoke that access. So you're a little bit more protected.
Cool. I have one fun thing, and this was just very timely. It kind of crossed my Twitter stream, I think yesterday. And this is for those of you who haven't listened to the talk that we had with Mark. Please do. It's amazing. We're talking about Kubernetes and...
No, with Mark Mandel.
Sorry. Yes, too many Marks. The chat that we had with Mark Mandel, we were talking about Kubernetes and what have you. And off the back of that, I realized I wasn't actually following the Kubernetes project on Twitter, which was an oversight that I've now corrected. They've got some amazing resources that they're slamming out on their blog, blog.kubernetes.io. And the latest one that kind of crossed my mind as like, this is a really nice solution to a problem is all about deploying Postgres SQL clusters using the new stateful sets feature in Kubernetes 1.5. So go and have a read of that, if only because obviously it's a fairly brief technical overview. It tells you how to do it, but at the same time it talks a lot about how you can use stateful sets, how you can use persistent volumes, and how you can solve the kind of pain point that is managing your database servers within Kubernetes, as opposed to having to just maintain it externally. So that's a really, really good resource, and I'll try and get that in the show notes as well.
We're going to have massive show notes this show.
They're huge.
They're huge. And I think that's it. I think this has been an interesting conversation.
I think so. Hopefully intelligent and informed. And hopefully useful. So,
get back to us. Rate us on iTunes. We want to be on the cover of iTunes at some point, right?
Do we do something if we get on the cover of iTunes? Should we incentivize this?
We just get loads of traffic, but
no, we get loads of traffic. I'm thinking like we'll pose for the Localhost FM naked calendar or something. God no, that's a terrible idea.
That's going to be like what? That's a terrible idea. Well, I'll take pictures of my puppies and make a Localhost puppy calendar.
There we go. That's a much better plan.
Plan.
Your puppies, my cats. There we go. We'll do the cute animal Localhost FM calendar if we get on the cover of iTunes.
Yeah, even if it's on the What's Hot, we don't care. Just rate us.
Yeah. If you, off the back of this, if you have any questions or, of course, corrections, anything that we've talked about today, then please do let us know. Say comment, email, tweet, and it's all Localhost FM or some variant thereof. You should be able to work it out. And likewise, if this has inspired you to kind of actually take the plunge and actually spin up CI and what have you, we'd love to hear how that goes for you. And yeah, stories from the trenches, always very, very welcome here on Localhost FM.
Oh, before we forget, we have one story from the trench. Robert Rawlins, he works for a thing called Sorry app, which is a status update. So you can see the downtime with a great status page. You can see, you can attach it to your application if you've got downtime. And he sent us a little story from the trenches. Says he's changed the way he works. He finds myself trickling a constant stream of stuff into production rather than fewer, bigger deploys. There you go. Stories from the trenches. We love them. Send them to the show at Localhost FM.
And this is it. We want to hear about your trickles of stuff.
Oh dear, no.
On that note,
thank you. I've been Mark Drew.
And I've been Rob Dudley.
Good day.